Hello friends, welcome to our .NET SDK CLI tutorial for beginners. Here we will teach you how to use the .NET SDK command line tools to create software for the .NET platform using different languages like C#, F#, and VB.NET. Now this is a hands-on tutorial that is aimed at beginners who want to learn how to use the .NET command line tools. So I will also teach you about the theory as well as a hands-on guide to how to build the software using command line tools. So first we will learn how to install .NET SDK CLI on your Windows system. And then we will learn about the basic .NET SDK CLI commands, like how to find help, what is the command structure, like what does .NET mean, etc. Then we will learn to create multiple different types of projects, like a console project here, a WinForms project, a WPF project, and also a web-based ASP.NET Core project. So after that, I will teach you how to add a NuGet package to your .NET project so that you can access other libraries or framework that are created by third parties. Now, once this is complete, we will learn how to create an exe file that you can release to the users. So you can either create a single file executable, that is a just .exe file that you can distribute to your users or customers. I will also teach you how to create a self-contained .NET exe file. That is a exe file that contains a built-in .NET runtime. And we will also teach you how to create one that is dependent, that is a framework-dependent .NET application. We will also teach how to target different processor or OS architecture using the .NET SDK CLI tools. So you can cross-compile your programs to target like a Linux, Windows, or a macOS system. Or you can also use it on a embedded system like a Raspberry Pi system. So these are the things you will learn in this tutorial. There is a text-based tutorial also that is on our website. The link is in the description. So all the commands that I am showing in the video are available in our website. The link to that particular website is in the description. So you can check it from there and you can copy the commands for creating your own .NET projects. This is a fairly long video, so I have added timestamps and you can find that in the description of your video. So you can navigate it to particular parts of the video. I have also added closed caption so you can understand this thing if you are unable to understand my voice. If there are any issues, tutorial, you can comment it on our comment section and I will try to answer it. The first thing we are going to do is to search for the .NET SDK on Google. So you can click on this particular link, which will take us to the Microsoft download site. So from here, we can download the .NET SDK. You don't need to download the runtime. Runtime is available with the SDK. So you'll be using this one, download .NET SDK for the 64-bit platform. And the runtime is .NET 8.0, which is the long-term support version. So you can click on this one and it will download the executable file. By the way, this is for the Windows platform. So you can download it. Just click save and it will download it. Now .NET SDK is available on other platforms like Windows, Mac OS X, and ARM platforms like the Raspberry Pi. So you can check out from here this one, all .NET 8.0 downloads. And from here you can find the SDK for your specific operating system. For example, we have the Linux here. We also have one for the Mac OS here and the Windows, which we have already downloaded. You can find the binaries here. In the case of Linux, you can go to the website, Microsoft website, and you can check the install instructions, like how to use it, how to install it on your specific Linux version. So most of the people are using, I think, Ubuntu. So you can go there and you can find the particular package manager and use it. So you can select the specific Ubuntu version. So this will show you how to do that. So all the details are here. You can follow it if you want to install the .NET SDK on the Linux system, especially the Ubuntu systems. Now, if you're a Mac user, you can follow the option available in the Mac. I won't be doing that right now. We'll be concentrating on the Windows version. So I have already downloaded the .NET SDK. It is on the desktop, this particular one. So you can double click on the executable file to install it on your Windows 10 PC. Now you can just press the button install and it will start installing. So once the installation is complete, you can fire up your command prompt. Then you can type the .NET command. You can just type .NET and then press enter. Now the SDK and the runtime are installed. So it is showing the usage and other options available with the .NET command. The .NET is called as the driver, which is used to drive other commands. So you can use the -h help to find out what all commands are available with the .NET. So I'll clear the screen now. So you can see .NET -h. So this will show the available commands that you can use it with the .NET. Now you can also check which SDKs are installed on your system and which runtimes are installed on our system using the .NET. So I'll clear it. And if you type .NET, it will show that we have to use this particular command, that is the list runtimes. So you can just type it like this. Then you can press enter. So this will show all the runtimes that are installed on my PC. As you can see from here, it has Microsoft ASP.NET Core along with the Windows desktop app and other stuff installed on this one. Now there is a reason that I also have a Visual Studio installed on my system. So some of these runtimes will be installed by the Visual Studio. So if you are just installed the .NET SDK, these runtimes may be different. So you can also use the list SDK to show the available SDKs that are on your system. So we showing the version number of the SDK. So that is this one. Now the term .NET is called as a driver, and it is usually used with another command. So it will be something like .NET new console. So this will create a new .NET console project, which you can write code and develop. So this particular one is called as the driver, and this one is the new, that is the command which is used to create a console project. This is one of the command options given to the new command. That will be this one. So let's say we want to know what all commands are available with the new commands. So for that purpose, we can use the help function. Let's say you want to know what all options are available for the new command. You can use the help like this one. So this will show the available arguments like -o for giving a specific output directory, and for -n for giving the name, etc. like that. So you can find the required commands using this option. Now we are going to create a simple console program using the .NET SDK CLI. So for that purpose, I have created a small folder called as .NET-CLI. This is just for testing purpose only. You can give it any name. So inside that folder, I'm using the command prompt here. You can create a new console project. For that, first we have to type .NET, which is the driver, and new, which is the command. And we have to tell the new command which type of project we have to create. So we'll be creating a console project. So you can type it console, and you can use the -n, which is to name your project. So I'm going to name it my console app. So this is the name of our project, and we'll now create the project. So you can press enter. So as you can see inside the .NET CLI folder, a new folder is created. It's called my console app. That is the name we have given to our project. So we have this particular folder. If you open inside that one, you can see the objective folder as along with the CS project file, this one, and the program.cs file. This is the program. This is the C# file which contains the program that we are going to run. So this is basically a hello world program. If you open it, you can see that one. So it will just show a hello world program when you run this thing. Now the CS project file will contain the type of project and the target framework and other details. This will change as we add more and more details to the project. Now you can build this project if you want to. So we will issue the build command. So that would be .NET build. This will build this program.cs and create an executable. So we'll press the enter. So we are actually inside the .NET CLI folder. So we had to change directory to the name of our app. So that will be my console app, this one. So you have to change the directory. So you can see that we can press dir and this is here. So we have to cd name of the project folder, go there. So if I dir, I can see the CS project and the CS file. That would be this one. So from inside this, you have to give the .NET build one. So you press .NET build. So you can see here that a bin folder has been created. This will contain the executable file. So the build is completed and there are no warnings or errors. So you can go inside the bin folder and you can see the debug folder is there. Inside that, you have the net 8.0 and you can see the my console app.exe here. And this is the debug information file. And this is the DLL file, which is required for running for the my console app.exe. Now you can run the code from here. You can simply say .NET run. So to show hello world, as you can see, it is showing hello world. So this is how you create a .NET console project and then run it using command line tools provided by the .NET SDK. Now you can also remove the compiler artifact by using the clean command. So you can do something called as .NET clean. This will delete all the files that has been created during the compiler process. For example, the exe, the JSON file, and the DLL files. So I'll press .NET clean. So all this file will be gone. Now you can rebuild it. So if you just call build, it will rebuild the whole thing. Now you're back in the .NET CLI folder. Now I'll tell you that the .NET SDK has the ability to create multiple projects. In the previous example, we have created only a console project, which does not have any graphical user interface. So now we are going to create a Windows Presentation Foundation project or a WPF project. So for that, you will use the same command, .NET new, but instead of console, you will simply write WPF. And you can give it a name, -m, my WPF project. So this will create a project and the required files are needed to run the WPF application. So I'll press enter. So as you can see, a new folder has been created. You can see all the XAML files which are required for creating the window and other stuff. If you run this program, it will generate a simple window. So you can edit the XAML and the XAML.cs file and do your programming. So I will just build this thing and run it. Or you can run it directly, then we'll press .NET run. As you can see, a window has popped up. So this is the WPF window. So you can edit the XAML file and you can change the appearance. Now we are going to create a WinForms project using the .NET SDK. So for that one, you have to write .NET new, and instead of console you have to write WinForms -n, name of your project. So I will call it, so this is the name of our project. So you can, now you can press it enter. We will create a folder. So if you go inside the WinForm project, you can see the familiar form1.cs and form1.designer.cs. So by editing it, you can add buttons and other things. Now you can run the code. This will also create a simple window. For that, you have to go into this folder and then you can see .NET run. This will create a WinForms empty window. Now you can see that form1 window is visible. Now you can close this one. Now one thing I want to tell you is that both the Windows Presentation Foundation and WinForms are now open source, and they are supported by the .NET platform, but only for the Windows platform. The WPF and WinForms are not available on Linux and Mac OS X. When you are developing, you have to develop it for Windows. We can also create web-based project using the ASP.NET Core and the C# language. So you can create a web project by typing .NET new web. Then you can name your project. So I'm going to name it. So this is the name of the project. And now we'll press enter. So this is going to create an empty ASP.NET project. So you can see the file is here. Now you can go inside the properties and you can find launch settings.json. So this will tell you which port number we will be using. So when you're running this thing, you know where to point your browser. So we can see that it is on localhost 5068. So you can copy this thing and place it inside the browser. So we'll run this thing right now. So we'll go into the folder. So from here we will use the .NET run. This will start the website and we'll locally host it. Now our site is live. You can see it in the browser window. It will show hello world. As you can see, it's showing hello world here. So you can use it to develop your own ASP.NET Core's website. Now let's close this thing. And now you have to press Ctrl+C. So the application is shutting down. So you have to press the Ctrl+C command to shut the thing off. So this is how you create a simple ASP.NET Core project using the .NET SDK. Now we are giving a lot of option to the new command using like web, WinForms, console, etc. These are called as templates, and you can use that to create standard projects. So you can go to the Microsoft website and Google .NET new, and inside that website you can see the various available templates. So I'll show you the templates right now. See, there is a list of templates that is available. For our console application, we are using console. And if you want a WPF application, you can use the WPF. So in this page, you can find all the required templates. So I have put a link in the description of my video, so you can check it out. Now in the previous tutorials, we learned how to create a console project, a WPF project, a WinForms project, and an ASP.NET Core project. Now in all these programs, we were using the default language, which was the C#. Now .NET platform supports different languages like C#, F#, and Visual Basic.NET. Now let's say you want to use Visual Basic.NET instead of the default C# language. So we'll have to use the language option. So you have to create something like this one. This is .NET new console. Then you have to give the :language. This one. Then you have to give the which language you're using. Here I'm using F#. Now let's say you want to use Visual Basic. You have to provide VB here. Now you can also use the -lang option. So I'll show it here. We'll create a new Visual Basic project. So we will call it as .NET new. I will create a console project. And you can give the language. Then we'll call the VB and we will name it as my VB project. Then this will create a console which will be using the Visual Basic .NET language. So we'll press enter. So here we can see we have created the VB project, and you can see that inside this one there is a file called as program.vb. So if you open it you can see the VB code here. You can also use a single lang also, like -lang also. This is also a valid option for selecting our language. Now you can also create an F# project. For that one you have to now this is an F# file. So if you know F#, you can code it using this one. This is how you select the language. If you don't provide any language options, the default language will be selected, which is actually C#. Here I would like you to introduce to our website. This is our website name, xanthium.in. I will put the link in the description. As you can see from here, we provide tutorials on various embedded systems like Arduino, Atmega 328P, microchip, and different ways to interface these particular microcontrollers to the PC. We also provide tutorials on languages like Python, .NET, like C#, Visual Basic .NET, etc. So you can check our website for these kinds of tutorials. We also manufacture embedded system products like the USB to serial converter that you can see from here, both the isolated one and the non-isolated one. Now we also have a companion website to this particular video. So the link to that particular website will be in the descriptions. So do check it out. So do check our stores also and our products like this one. This is a completely isolated USB to serial converter. So this is the USB section, and this is the RS-232 and the RS-485 converter. The whole section is completely isolated using both digital and power planes. So nothing, whatever happens wrong here will not be transmitted to your PC. So this thing is ideal for interfacing with different legacy USB to serial RS-232 devices or RS-485 devices. This is the device I was talking about. As you can see, the ground is completely isolated from here. And you have an isolated RS-232 port as well as an isolated RS-485 port. This is a DB9 port. We also have a screw terminal for RS-232. So if you don't need any isolated USB to serial converter, we also make a simple USB to serial converter. This one. Here we have this is non-isolated, but it has RS-485 port as well as the RS-232 port. Similar to the previous one, but non-isolated. So do check it out. If you want it, you can buy it from our store. When you are developing software for the .NET platform using C#, F#, or VB.NET, you may need to add third-party libraries or framework to your project. So we can use the .NET add package command from the .NET SDK to add third-party packages to our project. So this is the syntax of the command .NET add package, then the name of the package. So NuGet.org is a website onto which NuGet packages are uploaded. So you can go to that particular website, that is the NuGet.org, and you can search for the packages, or you can check the packages from here. So it will list different types of packages which you can install into your project file. So when you give the command .NET add package and the package name, the command line interface, that is the .NET SDK, will contact the NuGet.org and download the required packages and the references and other libraries to your project folder. It will also update your CS project file to make sure that the system recognizes that the particular package has been added to your project. Now we'll create a simple project in which we will be using a SQLite 3 library as well as the system.io.ports for accessing the serial port. Then we will learn how to add that particular package to your system. So we'll create a new console project. So we will name that as my console app SQLite 3. Then to this particular project, we will add third-party libraries like the SQLite 3 library as well as the system.io.ports. So first we'll create this particular project. We will now go to that particular directory. So we are in this directory right now. You can use the .NET add package. Now we have to use the package name. So I don't know which package. I don't know the exact name of the package. So one thing you can do is you can go to the NuGet gallery or the nuget.org, this particular website. And from here, you can search for the name of that particular library that we want to use. So I'll be using the system Microsoft.data.sqlite package. So I will type that name right here. So this is for accessing the SQLite library. So you can hit search here. So you can find that particular package right here. So you can see this particular line .NET CLI here. So we will get the exact command that we want to use it here. So you can copy it from here. Now you can see that this version is the preview version. So I want to use a different version. I want to use the stable one. So you can go to the versions tab here. That is under this particular .NET CLI. You can find the versions tab here. You can click on that. And this will show the different versions like this one. So I'll use the 8.05. So I'll click on that one. And you can see from here that this command line command has updated. Now it will be installing the version 8.05. So you can copy it from here and then use the command line from here. I will delete the old one right now. You can just paste this here, right? So we'll be adding this particular package. So you can press enter right now. And this will now install the package to our project directory. Now if you go inside that particular directory, now we are inside the My Console app SQLite 3 directory. So you can check this CS project file, and I will open it in Notepad right now. So inside this, you can see that the package reference include equal to Microsoft data.sqlite, and the version has been updated. So you can see that this particular package, the system knows that we have downloaded this particular package. So if I add another package, it will also be updated right here. So I'm going to add one more package. I'll just give it here. This will install the system.io.ports. This gives us access to the serial port class. Now if you go inside our project folder, and if you check our CS project file, you can see that the package reference has been added. Version is also added. So this is how you add the different NuGet packages to your project file for the .NET platform. So you can also list it programmatically. You can use the .NET list command to list the various packages that has been installed. So this is the command. It's package only. So you press enter. So you can see that these two packages has been installed for our project. So we can use the functions and classes which are available inside this particular libraries. We can also remove particular packages by giving the name. So you can remove the package by using .NET remove package name. So I will remove this one. So if I give this particular command, it will remove the Microsoft.data.sqlite 3. The other package will remain the same. I will list it again. Then you have to do a restore. Now I will list the package again. As you can see, only system.io.ports is available. The other one was removed using the remove command. You can see that this change has been reflected in the CS project file also. If you look inside that one, you can only find the system.io.ports. The other one has been removed. Now I will reinstall that one again. Now, if you want to know all these commands, you can check out our website. We have all the commands here. You can also check out the Microsoft website also for these commands. So here is the .NET list package command. So you can check our website if you want. So all these data is available in our website. So you can also add a reference to a local .NET assembly. Usually those are DLL files. So you can use the .NET add reference command like this one, and then you have to give the particular part to this .dll. The DLL file will remain local to your system. While when you are using the NuGet library, the .NET command is actually downloading all the data from the NuGet.org server. Once you have successfully created your software for the .NET platform using any of the available languages like Csharp or F#, you can now distribute the executable to your customers or users. So for that, you have to create an executable that is free from all the debugging information. So for creating that particular releasable executable file, we use the .NET publish command. So when you run this publish command, it will create an executable in a separate folder. So it will be something like this one. This is the name of the project folder, bin, release, then the .NET platform. Here I'm using .NET 8.0. So this one, and inside the publish folder, you can find the exe file. So we have created a simple project. This is the project actually. It's called as my console app, and it has a single file, program.cs, and it does not have any dependencies. So there's a small difference between a project that contains a dependency and a project that does not contain any dependencies. So we'll start with one without any dependency. So this is the source code for this one. It writes this particular line and it just prints the number 3 to the command line. Then it waits for the read line. That's it. You can use it, or you can use any other program. So you can use the .NET publish command to create the executable. So I'll do that right now. So we'll write .NET publish. Now this will create an exe file. Now the program is finished and it's showing where you can find the executable file. So it's inside bin, release, net 8.0, publish. So you can go here. Then inside the release folder, you will find the net 8.0. And there you can find the publish one. This is not the one. You have to go inside the publish folder. So inside the publish folder, you can find your application. So this is your application. And this is the DLL file associated with the application. So we also have two JSON files and the one called as myconsoleapp.pdb. This thing contains the debugging information. So you can delete it if you want to. Most of the code and other things are inside the myconsoleapp.dll. So if you remove this particular one, the exe file will not work. If you click here, this will create a window and it will show hello world and 3. So you have to press enter to exit from it. So this is around 140 kilobytes. If I delete this particular one, it won't work actually because most of the code are inside the DLL file. So when you have to give it to your customer or anybody, you have to give the whole folder, the whole publish folder along with these JSON files. You can delete this particular one. This is not required. So this is how you create a exe file. Now, if you don't want to create all, you want to send a single exe file instead of sending all this DLL. So we have an option to create a single executable file. So I'll go into that one next. If you want to change the output directory, you can use the -o flag. So let's say you want to put the executable file in a separate folder instead of the default one. So you can use the .NET publish -o, which stands for the output folder in which your exe file will reside. So I'll give it my release folder. That will be, so I'll press enter. So all the exe file will be inside this particular directory. You can see that this has changed. And if you go inside the my console app directory, you can see the my release folder. Inside this one, you can see all the required files, exe files and .dll files. This is how you change the directory to store your exe file. Now in the previous example, you learned how to create a exe file using the .NET publish command. But the exe file that was created was not a single file. It consisted of multiple files, including an exe file, along with DLL files and JSON files. Now you'll have to distribute the whole folder to the end user so that they can use your program. So in this one, we will show you how to create a single file executable that only contain a single .exe file. All the DLL files and JSON files will be combined inside that exe file. So it's easy for the end users. They can just download the exe and execute it. Now here I'm using a project called as My Console app, which is a very simple program with 0 dependencies. So it is very easy to make a exe file for a project that has 0 dependencies. In the next chapter, I will teach you how to make an exe file which has multiple dependencies. Now to create a single file exe, you need to use our old command .NET publish. Then you have to give the -p option. So -p option tells the .NET compiler is that we have to use the MS build tools, and we have to give the options after -p to the MS build so it can create a single file executable. So you have to give this particular option, publish single file equal to true. So you can find this option from our website. So you can give it here and you can press enter. This will create a single file now. Now the project has finished compiling and we can find the exe file inside this particular folder. So I'll go inside the bin, release, and inside the publish folder, you can find the my console app.exe. So now it is around 65 MB. So the size is 65 MB because we have included all the .NET runtime as well as the extra DLL files that were present earlier. So now the size is 65926. This is known as a framework independent app since the .NET runtime is already bundled with this thing. In the previous example, we learned how to create an exe file using the .NET publish command. Now in the previous example, the code was quite small. It doesn't use any external libraries or frameworks. So the publish output was quite simple. Now we will be creating an exe file for a CS project that uses different dependencies. So we have created a file called as my console app SQLite 3 when we are teaching you how to use the .NET add package command. So we will create a exe file for this particular project. So we'll go inside the project folder. So I will open the program.cs file. Now we know that we'll be using the Microsoft data.sqlite 3 and the system.io.ports. So I have created a small Csharp file which will create a serial port and a connection to the local DB, which is the SQLite 3 DB. Then it will open a connection to that DB and it will close it. Then it will just print this particular message. So this code will not do anything. I just want to call all the classes such that the relevant libraries has been compiled to the exe file. So we will compile this file first. So I will show, before you do that, make sure you have all the packages installed. So I have all the packages installed. I will use the .NET list package command to show that all the packages are installed. So we have these 2 packages already installed. So we can run this particular code. So now it's just printing hello from dummy code. So now let's create a exe file for this particular project. Now we will use the .NET publish command and I will stick with the standard output. You can use the -o if you want to make sure if you want to change the output directory. So I will stick with the standard one right now. So I'll press .NET publish. Now we will go into the output directory. So it will be inside the bin and we have to go on release and then you have to go inside the publish. So now this is the output for the project file with multiple dependencies. You can see that we are using the SQLite 3 library. So all the DLL for that SQLite 3 library are also included in the exe file output. I'll group it by type so you can see properly. So we are using the SQLite library. So this is that one. Then this is the DLL file containing our executable file. And these are the corresponding one. We are also using system.io.ports. So we'll have this particular DLL file also. Now this is our main executable. If I click it, So it will simply create a hello.db. We are not writing any data into the database file, so the size will be 0 KB. Now we can also find a particular folder called runtimes. So it will contain the runtimes for various platforms like the Linux, OS X, and Windows. So now you can see that the whole thing is a lot of folders and a lot of files. So we may need to make sure that we only need a single file. So for that, we have to give the single file option. The other thing I want to show you the size of this particular application. So this is 140 KB. So we'll create a single file exe for this particular project. So for that, we have to use so to create a single file, you have to use this particular command. This is -p and colon publish single file equal to true. Here -p is to tell the .NET command to use the MS build system. So all this particular option will be passed on to the MS build command and will create a single file executable. So I'll create one here. I'll use the same code. So you have to give the -p colon and publish single file equal to true. You can find all the commands that I am describing here on our website. The link is in the description, so you can check it from there. Now this command will stuff all the DLLs into a single file. Now you can go into the bin list folder to see the exe file. So earlier we went to the publish folder. Now it is inside the win-x64, and inside that there is a publish folder. So your exe file will be found inside that one. So you can find the exe as well as the esqlite3.dll and the pdb file. This is for debugging purpose. You can delete that one if you want to. So you can ship these two files together to your customer. So if I click this one, it will create a window. Now we have created a DB here also. As you can see from the size of this executable file, it is around 66 megabytes. Earlier it was somewhere around 200 kilobytes or something like that. So all the DLL as well as the required .NET components has been packaged into this particular exe file. So you can ship this file to any computer which is a Windows X 64-bit processor, and this file will run whether it has .NET runtime installed or not. So the runtime is actually included with the exe file. That is why the size is 66 MB. If you want, you can also combine this one inside this one. This DLL e_SQLite3.dll can also be combined inside the my console app SQLite3.exe. So for that, we have to give another option. That would be this one. -p include native libraries for self-extract equal to true. So what happens is that the DLL file is included inside the exe file, but when it is run, the exe file will self-extract and store the DLLs in a temporary folder, and then it will use it from there. So if I use this particular one, that SQLite3DLE will also go. So you can show you how it's done. So I'll create the publish single file equal to true, and then I'm also using the include native libraries for self-extract equal to true. This is basically creating a pseudo zip file. So we'll check our resulting executable. As you can see, we only have exe and the pdb file. You can delete it if you want to. So you can just execute the send this particular file, exe file, to your customers. The size actually increased because we are including that DLL file also inside this particular one. So I created a simple WPF project using the .NET new WPF command. Now I will turn that into a single file executable. So I'm inside that particular directory. So this is my WPF app, and you can find all the required files inside this one. Now I will change this into a single file exe file. Now we will use the .NET publish command. .NET publish -p colon publish single file equal to true. Now that's the usual way to create a single file. So I'll put it here. But since this is a WPF app, this won't create a single file. It will create a single file, but there will be a lot of DLL files. So I will run this program right now. So the program had finished executing. Inside the bin directory, release WinX64. Then you have to find the publish, this one. So you can see there is a single file executable, but there are also a lot of DLL files. So if you want to remove these DLL files, you have to use another command along with the publish file equal to true. So this is around 149 megabytes. That's because .NET runtime is actually inside this one. -p include native libraries for self-extract equal to true. Then this will create a true single file WPF application. So you can add that one. So you have to give -p single file equal to true. Also the other one, native libraries for self-extract equal to true. The command is in my website. You can check it from here. So we are in that particular directory, WinX64 publish directory. As you can see, we have a single app. It has increased its size to 158 MB. So this is a self-contained WPF application. So the .NET runtime is actually inside this one. And those .dll, they will be self-extracted to a temporary directory. So that's how you create a single file WPF app using .NET SDK. The .NET SDK command line tools allows us the creation of two types of apps. First one is called as the framework dependent app. That means that the app is dependent upon the .NET framework installed on the host system. While the second one, this one, is called as the framework independent app. Now, this is also known as the self-contained app. In this case, the .NET runtime is bundled along with the exe file. So these two apps actually refer to the final exe file that is released to the public. This is the block diagram of a framework dependent application. So as you can see from here, the yellow box within this dotted line represent the operating system. The operating system can be anything like Windows, Linux, or macOS, and our executable is this particular one, my console app SQLite3.exe. It's the same app that we have created in the previous examples. So we have an SQLite.dll and the system.io.ports DLL, my console app SQLite3.dll, and all the code that are required for this specific application are bundled together inside this exe file. So this is a framework dependent application. So only the required DLLs are packed inside this one. So when this particular application runs, that is my console app SQLite3.exe runs, it will communicate, it will check whether there is a .NET runtime installed on the computer. Then it will communicate with that .runtime and uses the resources provided by that particular .NET runtime. So for this particular app to work, we need to have a .NET runtime installed on this particular computer. If you are using a Windows system, we need to have a .NET runtime corresponding to Windows system. Same with Linux and macOS. So if this .NET runtime is not there, the exe file will not work. That's why it is dependent on the framework. Since only the required DLL files are packaged inside the executable, the size of this particular exe file will be small. And as we are not packaging the runtime into this one. So when you're distributing these types of files, you have to tell the user that you have to install a .NET runtime to run your application. Now, this is the block diagram of a framework independent application, also known as a self-contained application. This is similar to the previous one. So the yellow box represents the operating system. It can be Windows, Linux, or macOS. And we have our executable, that is the my console app SQLite3.exe. As you can see that we have the required DLLs, the SQLite DL and the system.io.ports DLL, as well as the my console app SQLite3.dll inside the exe file. Now we also can see that the .NET runtime and the required files are also packaged inside the exe file. So that's why it's called a self-contained application. So the system will not interact with the installed runtime since all the required files are inside the exe file. The exe file will work whether any runtime is installed on your host system or not. So you can easily distribute this to a user. so they can easily run it without installing anything. You can just double click on the my console app SQLite3.exe and the system will work. No need to install the runtime. So this is independent of the runtime. Now the major drawback is that it need to have a large size. So the previous one, only the required DLLs were there, so the size was small. Here we are bundling the .NET runtime also with the exe file, so the size will be quite large. So this is one example to show you the size difference. This is a framework dependent .NET app, so the size is around 2.4 MB, while the same app, which is now a self-contained .NET app with the runtime within the exe file, so the size has increased up to 68.2 MB. So you can see that the size actually increases dramatically when we are creating a self-contained .NET app, but it makes it easier for the end users, so because they don't have to install anything and the system will run. Now we are going to create a framework dependent app, and we will be using our old program, my console app SQLite3. This program would require a .NET runtime installed on our system to work properly. The easiest way to create a framework dependent app is to just use the .NET publish command. So this will create a framework dependent app, but it will also leave the extra DLLs inside the folder. So the app will be inside this particular folder. So this will be inside the publish folder. So you should remember that. So this is our app, and the size is around 140 kilobytes. Since we have a lot of dependencies, you can see the associated DLLs also here and the runtimes and other stuff. Now, if you send this folder, the application will work as long as the .NET platform is installed on that particular system. Now you can change it to a single file also. For that, you can change the command from here. So I will be using this particular command, .NET publish -b publish single file equal to true. And I will also include this particular option, -p include native libraries for self-extract equal to true. So that is to make sure that all the DLLs are inside the exe file. If it is a simple project with minimal dependencies, you don't require this one. So here we are having dependencies of our SQLite library as well as the system.io.ports library. We have to use this one. So we can create a single exe file. Now the one that is going to tell the compiler that we have to create a self-contained or a framework dependent file is this option, that is the -p self-contained equal to false. So this is self-contained equal to false. That means that we are going to create the framework dependent exe file. So you can copy the entire command from here. So this is the command I'm going to give. Now the code will be in this folder, bin release net 8.0, and it will be inside win-x64. Then inside that there is one folder called as the publish. That is the one we will get our. So this is our single file framework dependent app. So this has created a DB. I mean, we have not written anything, so the size will be 0 KB. And you can see that the size of this particular exe file is 2 MB because it is a framework dependent app. So you are not including the runtime with this one. Now you can see that there is a long list of directories to get to your particular publish file. So you can change it by using the -o option. If you send it to another computer that does not have a .NET framework installed, this will not work. Now we will create one that is framework independent. So for that one also, we will be using our old one, my console app SQLite3 project. So first thing we will do is we'll go here. We'll use the same command, but here self-contained equal to false. You have to write it as self-contained equal to true because we are creating a self-contained application. I will also create a new folder and I will call it as self-contained because we do not want to navigate the whole thing again. So I'll call it as self-contained. So this is the only change you have to make it, and you can press enter. Now here we can see that the self-contained exe file has been created and it is inside the self-contained directory. Now we'll go inside the self-contained directory, and here is our exe file. So you can see from here that the size is around 67.9 megabytes. So that's because the runtime is packaged with this particular exe file. Now if you send this exe file to another computer that does not have a .NET runtime installed, the system will work because the runtime is already bundled with the exe file. The .NET platform is a multi-platform framework. It can target multiple operating systems as well as multiple processor architectures. For example, it can be made to run on 32-bit and 64-bit x86 architecture, and it can also run on 32 and 64-bit ARM architecture. So you can run the .NET platform on a Raspberry Pi, and you can also use it for embedded system development. Now it also supports multiple operating systems like Windows. It supports the whole family, including the Windows 10, the Windows Server editions, and the Windows 11. It also supports multiple Linux distros like Ubuntu, Fedora, Arch, etc. And it also supports the Mac OS X. So you can build truly cross-platform applications using the .NET platform. Please note that the WPF and the WinForm graphical user interface is limited to Windows only. You cannot use that on Linux and Mac OS. Now, to target multiple processors or operating systems, the .NET platform uses something called as a runtime ID or RID. So you can go to the Microsoft website and you can get the full access, the full list of the RIDs. The link to the Microsoft website is actually in the description. So this is the .NET runtime identifier, and you can check it from here, the different types of architecture that is supported by the .NET platform and how to use it. So I will only mention the commonly used RIDs. That is something like WinX64. This is the default option. So whenever you compile something, the compilation is usually done for the 64-bit architecture. You can also go for the 32-bit Windows architecture using the Win-x86 RID tag. So for running Mac OS, you have to use the OS X-64-bit for the 64-bit Mac. Now you have the Linux also for both x64 and 32-bit Linux. Now if you want to run your code on 32-bit ARM microcontrollers, you can use this one. Now to compile for a particular architecture, you have to use the -R flag. This is the -R flag, and you have to give the runtime ID, that is Win-x64, or whatever you want to do. You can check it from here or use it from the Microsoft website. You can also use the --runtime also. Now I will use the My Console app. That is the one we have created earlier. This is the simple one, which does not have any dependencies. So I will create a .NET publish. Then I will give the runtime. I'm going to give the Windows 64-bit runtime. That is actually the default. So this will be that one. Copy. So this will be a multi-file exe. So there is a folder called Win-x64. You can find the exe file inside this one. So this is the 64-bit version of that particular program. So if you can use it for only 64-bit computers. So I'll create one for the x86 architecture, that is the 32-bit one. So I will be going for the Windows version. So you can get the correct RID from our website. So Win-x86 for 32-bit Windows. So you can change it here. So this will be created in a separate folder. Earlier, all our data was inside the Win-x64 folder, then inside the publish one. So it will create another called as Win-x86. As you can see, the exe file is inside the Win-x86 publish folder. So you can find it here. So if you go inside the folder tree, there will be two folders. This was the first one we created for the 64-bit one, and this is the 32-bit one. And there is the publish folder, and inside that you can find the 32-bit version. Now you can also create it for Linux also. You just have to give the correct RID. So I'll create one for Linux also. Linux one. So this will be Linux-x64. So these are command line programs. So it will work on almost all systems. So all your Linux files are inside this folder, and you can find it inside publish. So this is the executable. So this is a Linux file, so there is no .exe extension. So you have to run this thing on a Linux terminal. It won't work here. As you can see from the small size of the exe file, the .NET runtime is not included. So when you're running this code on, exe on other platforms, you need to install the correct appropriate runtime for this particular file. These are files that are dependent upon the runtime.